Dear students, Assalamu alaikum. From today, we are going to start giving you video lectures on the topics of physics that you have to cover in your new class. The first unit that we are going to start is the unit number 10, which is regarding simple harmonic motion. Simple harmonic motion, is a type of motion which is quite different from what we have been learning earlier. Up till now in motion, we have talked about translatory motion or rectilinear motion or a motion in a straight line. And then we talked about the circulatory motion. We talked about the rotatory motion. Now we are going to talk about a new kind of motion, which is a vibratory in nature or oscillatory in nature, and a special form of that is the simple harmonic motion. Idea 9 talked about translatory motion. Talked about circulatory motion or circular motion, rotatory motion, now we talked about the vibratory motion and a special type of it is simple harmonic motion. What does motion do, as we have learned in 9th class? What does motion do? Motion transfers energy from one point to another. Translatory motion is the motion of the straight line. It transfers energy from point A to point B. Circular motion is the motion of a stone which you tie around a string and you revolve in a circle. And rotatory motion is the kind of motion that you see in the electric fan, which is called spinning of the top. The spinning motion is rotatory motion, and vibratory is to and fro motion. To and fro motion. About a fixed position. The to and fro motion, you have seen the motion of a spring, of a swing. The motion of a swing is a kind of motion in which there is the central position known as the equilibrium position or the mean position, in which normally a swing hangs. This is the mean position or the equilibrium position. When you take a swing and you go on this side, in that case, on this extreme position, then you move away from the main position. And then you come back towards the reverse direction. And you keep swinging around the fixed point, the mean position or the equilibrium position. A to and fro motion, यानी आगे पीछे जाने वाली मोशन को हम वाइब्रेटरी मोशन कहते हैं, या इसकी एक फॉर्म ऑसिलेटरी मोशन भी है. और इसकी एक special form is about the simple harmonic motion. The purpose of this motion is also to transfer energy from point A to point B. Now consider the case of a mass which is attached to a spring. Mass attached to a spring. This is a position of where the spring has been fixed. Now this is a mass, a body of mass M, which has been, it is attached to a spring. Now consider, again I repeat, we are now going to consider the motion of a mass which is attached to a spring. This is the spring, this is the main position of the spring or the equilibrium position. You apply a force and pull it towards the right. From here you move on this side. Or in other words, the spring now you have pulled from this main position to this main position to a distance x. I come again and try to tell you again. Consider a body of mass M attached to a spring and lying on a horizontal, smooth, frictionless surface at its main position. You apply a force F and you pull the spring towards right through a displacement x. Now when you pull the spring, a restoring force will act upon the spring, which will try to bring it back to the main position. This restoring force F is directly proportional to the displacement x that you have made. The more you pull the spring towards right, the more will be the restoring force trying to bring it back to the main position. And when you release this after pulling it on the right, the mass will try to move towards left and it will come to stop when the restoring force has been removed. Now the body of mass M, the spring was pulled towards right toward displacement x. A restoring force acts upon it, which is directly proportional to the displacement x. The more the displacement, the more the restoring force trying to bring it back to the main position. When you release, it starts going towards left, and when it comes at the main position, this velocity of the mass is so much that it overshoots the mark of the main position and compresses the spring on the left side through a displacement x. So the spring will keep oscillating between one extreme position to another extreme position. It will keep moving right and left, right and left, right and about in main position due to the restoring force. This force F, which is acting upon the spring, this force F acting upon the spring is directly proportional to the displacement x, and we give it a negative sign because the force is applied in this direction. We apply, but the restoring force acts in the opposite direction to the displacement, so with a negative sign. Or F is equal to minus kx. So the restoring force is directly proportional to displacement. The more the displacement, the more the pull on the right, the more restoring force, and it is in opposite direction to the restoring force acts in the opposite direction towards the mean position. So with a negative sign, F is equal to K, where K is the spring constant. But we know that F is equal to MA So MA is equal to minus kx, or A is equal to minus k over m into x. Or you can say A is proportional to x. The acceleration produced in the spring is directly proportional to the displacement and acts towards the mean position. From here we can calculate the time period. What will be the time period? What is time period? This term is time period. Time period means the period, the time taken to complete one vibration, the time taken to complete one period or one circle or one cycle. In case of the mass attached to a spring, it goes towards the right on one mean position, then goes towards left on the second extreme position after crossing the mean position, and again comes back. So one round trip of the spring from here to here and then here and then coming back to the mean position is one vibration or one period. So time taken to complete this period is known as the time period. And this is determined by how we find T, capital T is equal to 2 pi under root m over 2. This is the formula for finding the time period of a spring attached to a mass. Now we can take another example of simple harmonic motion, in which case we take a ball which has been placed in a bowl. Earlier, I talked about the mass attached to a spring which was performing simple harmonic motion around the mean position. Now we take the second example, in which we take a ball and ball system. We have a ball where we put a ball at the center. The weight of the ball is acting vertically downwards and the reaction of the ball in the upward direction. Since no motion is taking place over here, so the weight is balanced by R. Now we pull the ball and we take it to one extreme position A and then release it. When we take the ball to this extreme position, the only force acting upon it is the weight of the ball, which moves towards the mean position. When it reaches the mean position, it overshoots the mark because the velocity that it has gained due to inertia or due to the weight overshoots the mark and reaches the second position B. So the ball keeps moving between two extreme positions A and B like this. This is also an example of a simple harmonic motion, to and fro motion above the mean position O, and it goes to one extreme position and the second extreme position. We take another example. Now we take the example of a simple pendulum. In a simple pendulum, as we have seen, we take a string of length L and we place a small ball at one end. Whose weight is equal to W pi c. Whose weight is W, and you pull it towards the right through a small angle theta, and then you release it. When you release it, the ball starts performing simple harmonic motion from one extreme position A to another extreme position B. This is also an example of simple harmonic motion in which the body is moving around the mean position, and this is the case of a simple pendulum or a swing. When you pull the ball from this position O to the extreme A and then release it, then the only force acting upon it is, if you resolve weight W into rectangular components, and the only force acting is mg sine theta. The weight of the ball, the cos theta on around this, suppose T is the tension in the string, this is balanced by this mg cos theta. Since there is no motion, so T is balanced by mg cos theta, and the only force acting is mg sine theta. Because of this force mg sine theta, the ball keeps performing simple harmonic motion about its mean position, going from one extreme A to another extreme B. The time period of this simple harmonic motion, of course, is as given earlier, as told to you earlier. That time period is the time taken to perform one period or one cycle. And one cycle of a simple pendulum is going from the mean position to another mean to A, then coming back, going to second extreme position B, and then again B. So one round trip from the mean position O to A, back to B, then to O is known as one cycle of period. So time period T is equal to, this is 2 pi under root L over G, where L is the length of the string, G is the acceleration due to gravity. This is how you calculate the time period in case of a simple pendulum. Now coming back to this thing, what is simple harmonic motion? It is a kind of motion which is to and fro motion which oscillates between, vibrates between point A and the extreme position. The acceleration is always directed towards the mean position. The acceleration is always directed towards the mean position and is equal to the displacement from the mean position in magnitude. As we talked about in the case of a mass attached to a string, acceleration is directly proportional to the displacement from the mean position, and it is directed towards the mean. So simple harmonic motion is a kind of vibratory motion in which a body vibrates to and fro about the mean position, and acceleration in it is always directed towards the mean position and is proportional to the displacement from the mean position. Motion. The first thing is that a body executing simple harmonic motion always vibrates about a mean position. I come again. One of the main features, one of the main characteristics or the property of simple harmonic motion is it always executes a vibratory motion about its mean position. Second, the acceleration is always directed towards the mean position. Third, the magnitude of acceleration is always directly proportional to the displacement from the mean position, and the velocity of the body executing simple harmonic motion is maximum at the mean position and minimum at the extreme positions. I come again, the main features of simple harmonic motion यानी इसकी खुसूसियात क्या है? पहली, जो भी जिस्म simple harmonic motion perform कर रहा होता है, anybody performing simple harmonic motion moves to and fro about a mean position, किसी mean position पे गिर होती है. Number 2, इसमें acceleration हमेशा mean position की तरफ होती है. Number 3, इसकी magnitude is always proportional to the displacement from the mean position. Mean position से कितना दूर लेके गए आप उसको displacement from mean position क्या है? जितना दूर है उतनी acceleration की magnitude ज़्यादा होती है. And number 4, when the body is executing simple harmonic motion, the velocity of the body is minimum at the extreme position and maximum at the mean position and minimum at the extreme position. ये यहाँ चार features हैं इसके, and the time period of a simple harmonic motion in case of a simple pendulum is T is equal to 2 pi under root L over G, where L is the length of the string, G is the acceleration due to gravity. Some more things that I would like to talk about is vibration. What is vibration? One complete trip or revolution of a body executing simple harmonic motion about spin. So what is vibration? One complete round trip of a vibrating body about its main position. Second is time period, that is the time taken to complete one cycle of vibration. Third is frequency, the number of vibrations performed per second. How many times does it oscillate about the mean position in 1 second? That is the frequency. And the fourth is amplitude, the maximum displacement of the body from the mean position is known as the amplitude. In case of a ball and boat, how much far away you take it. In case of a cylinder, how much far away you take it from here. So that is the amplitude, the maximum displacement of the body from the mean position. In case of a mass attached to a string, how much did you pull it towards the right or you compressed it towards the left, is known as the amplitude. Thank you.